Hello students, how are you all? I hope everyone fine. So we are in last part of vectors, where we are going to learn one more product, but product of three vector, and it is known as scalar triple product. Okay, scalar triple product. Observe carefully. I'll take some products here of three vectors. Vector A dot B dot C. See here also it look like product of three vectors. A cross vector, okay, B cross C, okay, A dot vector B cross C, vector A cross vector B dot C. Out of these four different types of products, remember, out of these products, two are never possible. Two never exist. Only two exist. Out of that, one is scalar triple product, another one is vector triple product. But vector triple product is not there in syllabus, so only we are discussing about scalar triple product. Okay. So out of these four, which is not possible? Can you tell me? One is A dot B dot C. Is it possible? No. Why it is not possible? Vector dot scalar is not possible. Remember that. Vector dot scalar is not possible. Vector dot scalar is not possible. Vector cross vector. It is possible. Vector cross vector possible. So this is exists. The second one exists. Third one, vector A dot B cross A. Vector dot vector. Even this is also possible. Okay, so even third one is also exists. Fourth one, vector A cross B dot C. Vector dot scalar. Vector cross scalar is also not possible. Is also not possible. So this is not exist. So which two are exist? The middle two are exist. Remember, the first and last does not exist. Out of these two, observe carefully, cross product between two vectors is a vector. So definitely this product will be known as vector triple product. And dot product between vector, okay, is a scalar, and so it is known as scalar triple product. So we are going to learn about this product in this year. The vector triple product is exist, but it is not there in your syllabus, so don't worry about that. Vector A dot B cross we are going to learn, that is known as scalar triple product. Start with the definition of scalar triple product. Okay, the definition is as follows. Observe carefully. Let vector A, B and C be any three vectors. So we need, since it is a triple product, we need three vectors. Let it be A, B and C. Then the scalar triple product of ABC is a scalar. Already you know, because dot product between vector and vector will be always a scalar. So it's a scalar. Vector A dot B cross C. Vector A dot B cross C. Remember that. And it is denoted by like this, with the separated by commas. Square bracket compulsory, it should be a square bracket. Remember, okay? So it is also known as box product. Another name of this product is called box product, because we write inside like a box, okay, square bracket. So remember, vector A dot B cross C is nothing but vector A comma B comma C between the two square bracket, understood? So it is scalar triple product A dot B cross C. Scalar triple product is a scalar, vector A dot B cross C, and it is denoted by like this. Yeah, from the definition you will not understand exactly what it is, but when you learn its properties you will come to know exactly what does this represent, why this is introduced to mass. Okay, understood what do you mean by scalar triple product? I mean, definition I'm asking, still so many things are there to learn about the scalar triple product. Okay, as a properties. First property, okay, of this scalar triple product is the analytical meaning of the scalar triple product. See, from the definition of A dot B cross C, you cannot find out exactly, okay, what is the scalar triple product of the three vector when its components are known. Now, as a first result of the first property, we are going to learn how to get the the scalar when the components of the vectors are known. That is vector A, B, and C. You know it's everything about components. Observe carefully. So when you know the components of ABC, so that this property will help you to get the value of the scalar. Okay, so A dot B cross C is nothing but determinant. Yeah, maybe exactly you don't know about it, but you're going to learn it. Don't worry. So maybe some of them learn half. Okay, don't worry about that. You will understand. And simple work. It's a determinant A1, A2, A3, B1, B2, B3, and C1, C2, C3. I'll explain how I got this. Observe carefully. So take first B cross C. I hope you know how to get the B cross. It's a determinant I, J, K, alva. What is second row? B1, B2, B3, third row C1, C2, C3. Now you are going to expand this, right? What is the expansion of this? So maybe you understood how to expand, at least, I mean, you just learn that part of the determinant here, okay? I delete that row and column. E row and the column, okay? What is remaining? Like B2, B3, C2, C3. So multiply first like this, minus multiplication of this. That is B2, C3 minus C2, B3. Okay, then minus, always second term will be minus, start with the minus. J, first column, first row, second column, you have to remove this and this. So B1, B3, C1, C3 remaining. So B1, C3, other order, minus C1, B3 plus K, first row and the last column you have to remove. So that is this product. So B1, C2 minus C1, B2. So this is what vector B cross C. Now what is required? Vector A dot B cross C is required. Dot product, so that is A1 into coefficient B2 C3 minus C2 B3, okay, plus or minus here, okay, because here this coefficient is negative, or you can write ulta also, okay, let it be minus, nothing to worry. So A2 into B1 C3 minus C1 B3 plus A3 into B1 C2 minus C1 B2. And observe carefully, this is nothing but the expansion of the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. You can check this. This is nothing but this. This is nothing but this determinant. I'll show you, okay, why this is same. Observe carefully, expand this A1 into B2 C3 minus C2 B3 alva, notice first term aa gaya hai. Then minus A2 into B1 C3 minus C1 B3 alva plus A3 into B1 C2 minus C1 B2. Compare madi, exactly it will match. So you can agree with this that vector A dot B cross C is nothing but a determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. This is very, very important result, because only this will help you to get the scalar triple product of three vectors when you know all the components of the three vectors. So remember, it is a scalar. Illa ijk barudilla, confusion agbidi, ijk barudu, cross product alli scalar product la ijk barudilla. So only the numbers A1, A2, A3, the first row it are the coefficients of the vector A, components of the vector A, second row components of the vector B, and third row components of the vector C. Direct expand money, you will get real number, not a vector, a scalar you are getting. Understood? Very good. So remember this process. Proof you may not record in exam, but the result is very important. Okay. So next property, the second property of scalar triple product. See, observe carefully. Lane birthday nodi. If you, this is nothing but scalar triple product, right? If you interchange A to B, B to C, and C to A. If you interchange, or if you rotate this ABs in cyclic order, if you rotate ABs in cyclic order, there is no change in the value of the scalar triple. This property says that, okay? This position, move element and okay, or cyclic order change there is no change in the value of the scalar triple product. Remember, okay? Similarly, B changes to C, C changes to A, and A changes to B. Cyclic order and then like this: A, B, C. E orderly rotate there is no change in the value of the scalar triple product. This is very useful result. You will get this in exam. So if you rotate ABs in a cyclic order, okay, there is no change in the value of the scalar triple product. But observe the next one. What is the difference between these two? See, illi now cyclic order li ellanu mooru vector change madideva. Correct agi observe madi. First ಅಲ್ಲಿ ಮೂರು ವೆಕ್ಟರ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡಿದ್ದೇವೆ ಅಲ್ವಾ? A ಇಂದ B ಗೆ, B ಇಂದ C ಗೆ, C ಇಂದ A ಗೆ. All the three vectors are changed, okay? But out of three here in the second property, only two are rotated or changed, or the interchange. This is called interchange. If you just do the interchange of two position, maybe AB or maybe AC or maybe BA, whatever, okay? If you interchange the two position out of three in a scalar triple product, only one pair, then there is a minus sign enter in the value of the scalar triple product, okay? The minus sign will enter in the value of the scalar triple product. Remember that, okay? So I'll show you, I'll explain. This is not a proof, just explanation. See, then vector A dot B cross C, alva. Correct? Now this, okay, let it be, this is the left hand side. What is right hand side? Vector B dot A cross C, right? Now this I can write as a B changes to C, C changes to A alva, dot A changes to B, B changes to C, correct? C changes to B, B changes C changes to A changes to B, correct? ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? I'm using the first property. Rotate all the three in a different way, you will get the value. Now this is also equal to minus of vector A dot B cross C, correct? Did you agree with me? So this is nothing but the right hand side, vector B comma vector A comma vector C. Now this is equal to, minus of vector A comma vector B comma vector C. So when you interchange the position, only change in the value of the scalar triple product is the minus sign. The magnitude remains same, only the direction changes, that is minus will come. ಅರ್ಥ ಆಯ್ತಾ? ಪ್ರೂಫ್ ವಿತ್ ಪ್ರೂಫ್, ಕಂಪ್ಲೀಟ್ ಪ್ರೂಫ್, ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅಲ್ಲ, ಪ್ರೂಫ್ ಆಗಿ ಕೊಟ್ಟಿದ್ದೇನೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ಎರಡೇ ಎಲಿಮೆಂಟ್ ಪೊಸಿಷನ್, ಎರಡೇ ಎಲಿಮೆಂಟ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡಿ, ಎರಡೇ ವೆಕ್ಟರ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡಿದ್ರೆ, ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿದ್ರೆ, ಯು ವಿಲ್ ಗೆಟ್ ದ ಮೈನಸ್ ಸೈನ್. ಬಟ್ ಇಫ್ ಯು rotate ABC in a cyclic order, there is no change in the value of the scalar triple product. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ಸೊ ವೆರಿ ವೆರಿ ಯೂಸ್ಫುಲ್ ಪ್ರಾಪರ್ಟೀಸ್, ಓಕೆ, ಸ್ಮಾಲ್ ಆಗಿರ್ಬೋದು ಬಟ್ ವೆರಿ ವೆರಿ ಯೂಸ್ಫುಲ್ ಪ್ರಾಪರ್ಟಿ ಇನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಪಾರ್ಟ್. ಓಕೆ, ಸೊ ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್ ವಾಟ್ ಐ ಮೀನ್ ಬೈ ಸ್ಕೇಲಾರ್ ಟ್ರಿಪಲ್ ಪ್ರಾಡಕ್ಟ್, and the first property very important to get the value of the scalar triple product, and these two properties. Understood what I'm telling? Yes. So next one, it's a very important concept. Again, proof you may not get an exam, but the value, the result of this concept is very very important. Usually you will get 1 mark, 1 3-mark question from this concept. Observe carefully. You saw this in scalar product as well as vector product, the geometrical meaning. Okay, so geometrical meaning of A dot B cross C. Exactly now you will understand what this represent, what A dot B cross C represent. Okay, geometrical meaning of A dot B cross C. Let OA is equal to, this is OA, okay, let OA is equal to A, OB is equal to, B, this is a vector B, this is a vector A, and this is a vector C. Interchange ಮಾಡಬಹುದು, it's okay, nothing to worry. Are the three co-terminal edges, co-terminal is this three, the mark which is red are called the co-terminal edges of the parallelepiped or parallelepiped. ಹೇಗೆ ಬೇಕಾಗಿ ಓದಬಹುದು, parallelepiped. Parallelepiped ಅಂದ್ರೆ 3-dimensional picture of parallelogram. Then consider vector A dot B cross C, because we need the geometric meaning of A dot B cross C, so consider that. Use a geometrical meaning of dot product. Geometric meaning of dot product, vector A dot B ಅಂದ್ರೆ vector magnitude of vector A into projection of vector A on vector B on A alva. A dot B, remember geometric meaning of vector A dot B is magnitude of vector A into projection, okay, of vector B on A. ನೆನಪಿದೆ ಅಲ್ವಾ ಇದು? So I am using that. So A dot B cross in the magnitude of vector A, correct? Or so I am using the geometrical meaning of the dot product. A dot B is also known as the projection of one vector on another vector, right? So here I'll consider magnitude of vector B cross C as A into, okay, I'll write below, magnitude of vector B cross C into projection of, okay, projection of vector B cross C on vector A. Projection of vector B cross C on vector A. B cross C ಎಲ್ಲಿ ಬರುತ್ತೆ ಹೇಳಿ? This is the direction of B cross C ಅಲ್ವಾ? Perpendicular to both B and C. This is B cross C, ನೆನಪಲ್ಲಿ. B cross C is always perpendicular to both B and C, right hand system. ಇದು B ಇದೆ ಆದ್ರೆ B cross C ಎಲ್ಲಿ ಬರುತ್ತೆ? ಇಲ್ಲಿ ಬರುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಆ ಡೈರೆಕ್ಷನ್ ಬರ್ದಿಯಾನೆ. ಸೊ magnitude of B cross C into projection of vector B cross C on A. ಸೊ ಅದು this projection ನೆನಪಿದೆ ಅಲ್ವಾ? ಸೊ magnitude of B cross C ಅಂದ್ರೆ ಏನು? Area of the base, area ಅಲ್ವಾ? Magnitude of B cross C, you learn geometric meaning of cross product. So area of the base into the projection of vector B cross C on A is nothing but height of the parallelogram, parallelepiped is nothing but height. And also area of the base into height represent, yeah, exactly, area of, okay, product of area of the base and height represent volume of what? Volume of the parallelepiped pipe or anything, okay, because no problem. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ದ geometric meaning of A dot B. A dot B is also equal to magnitude with this into projection of this on A, the B cross C on A. B cross C direction ಹೀಗೆ ಬರುತ್ತೆ ನೆನಪಿರಲಿ, perpendicular to both B and C. ಅದು projection ಅಂದ್ರೆ ಅದು shadow on the wall, that is height of the parallelepiped. B, magnitude of B cross C, already you learned, it's nothing but area of the base in, okay, geometric meaning of cross product. Area of the base into height represent volume of the parallelepiped. Represent volume of the parallelepiped. Got it what I'm telling? So remember vector A dot B cross here, the scalar triple product of three vector is always represent volume of the parallelepiped. Parallelepiped and the three-dimensional picture of parallelogram. Volume, not area, because three-dimensional. Volume of the parallelepiped with the co-terminal edges vector A, B and C. Understood what I'm telling? So the important information, a proof is maybe not important, but the conclusion is there. No, it's very very important. It represents volume. Very good. Okay, so fifth property of the scalar triple product is if two vectors out of three vectors are collinear. If two vectors out of three vectors are collinear, then the scalar triple product is zero. Then scalar triple product is zero. Okay, I'll explain what I mean by that. Collinear andre gottide alva. So two vectors. Let us, for example, vector A dot A cross C. Vector A dot A cross C. Here A and A are collinear, obvious. Two same vectors are collinear, parallel vectors are collinear, alike and unlike vectors are collinear. I hope you know what I mean by collinear concept. Okay, so A dot A cross C. So according to the definition, suppose components are A1, A2, A3, B1, B2, B3 and C1, C2, C3, then it is nothing but determinant A1, A2, A3, A1, A2, A3 and C1, C2, C3. Alva? Expand ಮಾಡಿ ಏನು ಬರುತ್ತೆ ನೋಡಿ. A1 into A2 C3 minus C2 A3 minus A2 into A1 C3 minus C1 A3 plus A3 into A1 C2 minus C1 A2. You check this, all the terms cancel. For example, see A1 A2 A3 A1 A2 C3 they are plus A1 A2 C3 minus cancel. ಅದೇ ತರ A1 C2 A3 minus plus ಏನಿದೆ A1 C2 A3. See, cancel. So ಎಲ್ಲ cancel ಆಗಿ, so remaining is 0. So remember, out of three vectors, when two vectors are collinear, then scalar triple product is 0. One more example, if I take vector A dot 2 into vector A cross B, even this is also 0 because here these two vectors are collinear. Athwa vector B dot vector A cross 3 into vector B, even this is also 0 because here these two vectors are collinear. 0. So remember, scalar triple product will be 0 when out of 3 two vectors are collinear. Collinear, one is a multiple of another. Out of 3, when two vectors are collinear, then remember that scalar triple product is 0. A very 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 important result. Out of 3 vectors, when two vectors are collinear, scalar triple product 0. I explain with the example also. Observe carefully. Artha aita? We have another situation where again scalar triple product is 0. Okay, observe carefully. If three vectors are coplanar, then scalar triple product is again 0. When three vectors are coplanar, scalar triple product is 0. Coplanar adre enagate? Coplanar andre no belongs to the same plane. Suppose if three vectors are coplanar, then is it possible to have a parallelepiped using these three vectors? See, geometric meaning of scalar triple product, you know, the A dot B cross C represent volume of the parallelepiped where A, B, C are the co-terminal edges. You can observe in that diagram, they are belongs to the three different plane. Correct? This is vector A, this is vector B, this is vector C. They are belongs to the three different plane. They are not in the same plane. They are belongs to the three different plane. Suppose these three co-terminal edges belongs to the same plane, then what will happen? If these three belongs to the same plane, then there is no parallelepiped. Andre volume baro chance illa. So it is equal to 0. When out of all the three vectors are coplanar, it is not possible to have a parallelepiped then purely because possible only when the three vectors are belongs to three different and mutually perpendicular planes. Remember, there must be mutually perpendicular planes. So when three vectors are coplanar, please remember that scalar triple product is 0. Scalar triple product is 0 because no parallelepiped is possible. Diagram possible agudu. Geometrical meaning in diagram nodidire adu possible illa. So volume illa andre 0. Artha aita? So remember, scalar triple product will be 0 in two cases, when 2 out of 3 vectors are collinear and all the 3 vectors are coplanar. Eradu very 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 important information, please remember that. Okay, so explanation, I hope you understood. I took one example, vector A, B and C is given. You need to find out scalar triple product. One simple example for that first statement. I'll write here, okay, solution I'll write, the space may not be enough. So 1, 2, minus 3, directly you are writing the determinant, okay. Observe carefully here, I coefficient illa andre 0, 2 minus 3, and expansion, directly expand. Suppose expand ಮಾಡೋದಕ್ಕೆ 0 ಬಂದ್ರೆ ಏನು ಅರ್ಥ? Maybe 2 out of 3 vectors are collinear, or maybe all the 3 vectors are coplanar. Okay, let us check. Expansion ಗೊತ್ತಾಗಲಿಲ್ಲ ಮತ್ತೊಮ್ಮೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಈ ಒಂದು ಎಲಿಮೆಂಟ್ ಯೂಸ್ ಮಾಡೋದು ಅಂತಂದ್ರೆ ಫಸ್ಟ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಡಿಲೀಟ್ ಮಾಡಬೇಕು, ಲೈಕ್ ದಿಸ್. -3 into -3 is +9, -4 into 2 8. Okay, next always minus, delete this and this, so this into this, this into this. So -3 into -2 -6 0, -3 this is -3 alva, only minus plus actually, but because of this minus here also you will get minus into delete this row and this column, so 2 into 2 4, and another one is 0, so this will be 1 plus 12 alva and minus 12, so it cancel agate, so 1 cubic centimeter cubic meter you volume alva, so answer is 1. So the scalar triple product of this particular A dot B cross C is nothing but 1 unit, is a scalar, ij ke baro chance hai. I hope you understood. So today we learned definition of scalar triple product and its properties. So and problems we are going to continue. Okay, artha aita idu part, very good. Okay, so we learned properties of scalar triple product. Now problems. So this is the last exercise in vectors, remember that. Okay, so first question, we have to find out scalar triple product. Already explained this concept with an example, so I'll repeat the same explanation. Okay, so we need now scalar triple product of 3 vectors. As you know, it is nothing but the determinant 1 minus 2 3, then 2 minus 3 1, 3 1 minus 2. I hope okay you understood now the expansion of the determinant. Just expand 1 into 6 minus 1 plus 2, actually minus already itti on minus barate, minus 4, okay, minus 4 into minus 3 plus 3 into 2 minus of minus 9. So it is 5 here, minus 14 because 7 into 2 is 14, this here 11 33. So 38 minus 14 and 4 24. Understood? So always you will get scalar triple product as a number, real number, because it is a scalar, so that real number is 24. Artha aita? Very good. This is already done once. Okay, it's a repetition. First question exercise, so I took. Next one. These are the important questions. These remaining few questions are very very important. So out of that, the next one is show that the vectors are coplanar. You know scalar triple product will be 0 when 3 vectors are coplanar. So directly write its determinant. Okay, you know 1 minus 2 3, minus 2 3 minus 4, 1 minus 3 5, and show that this value is equal to 0. So direct expansion again, 15 minus minus plus plus again minus, so it's 12 plus 2 into minus 10 plus 4 and plus 3 into minus minus plus 6 minus 3. So it is 3 illish barate 6 minus 12 here plus 9, so it is equal to 0 alva. 9 plus 3 12, 12 minus 12 0. So 3 vectors are coplanar. Why? Scalar triple product is 0. 3 vectors are coplanar. Our vector are coplanar. Remember, 3 vectors are coplanar because its determinant is equal to 0. Artha aita? Next, find lambda if the vectors are coplanar. Again same idea, 3 vectors are coplanar, you have to find out the value of lambda. The determinant is equal to 0. So again this is very simple, 1 minus 1 1, 3 1 2, 1 lambda minus 3. Now don't try to prove it is coplanar because it is given that it is a coplanar, so use the condition that it is coplanar. So expand this, 1 into minus 3 plus minus 2 lambda alva, minus 3 minus 2 lambda plus 1 into minus 9 minus 2 plus 1 into 3 lambda minus 1. So this is equal, okay, equal to 0. So this implies minus 3 minus 2 lambda minus 11 plus 3 lambda minus 1. So it is lambda, here you will get minus 14 minus 1, so 15. So lambda is equal to 15. That's it. ಅರ್ಥ ಆಯ್ತಾ? ಈಕ್ವಲ್ ಟು 0 ಇದೆ ಇಲ್ಲಿ. ಸೊ ದಿಸ್ -1 -3 -11 ಎಷ್ಟಾಗುತ್ತೆ? -15 and -2 lambda plus 3 lambda ಅಂದ್ರೆ lambda, so lambda is equal to 15. So for this value of lambda, this determinant is equal to 0. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? ಸೊ ರಿಮೆಂಬರ್ ದಿಸ್ ಸಿಂಪಲ್, ವೆರಿ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್, ಬಿಕಾಸ್ ಆಲ್ ದ ಪ್ರಾಬ್ಲಮ್ ಬೇಸ್ಡ್ ಆನ್ ದ determinant concept. Okay, next one. This is also very important. Next two problems are very important. Usually this question you will get in exam for 3 marks. Observe, question is same almost, but one work is extra compared to previous one. Show that the 4 points with the position vectors are coplanar. Andre 4 points are given. 1 2 3 4 points, A B C D. To prove that these 4 points are coplanar, you have to prove that any two vectors formed by, any two vectors formed by these 3 vectors are coplanar. If you prove that 3 vectors are coplanar, which are the vectors using ABCD, then you can write that ABCD are coplanar. So these are all the position vectors. Remember that this is OB. Okay, so directly first find out AB, AC and AD. Okay, these are the 3 vectors using the 4 points. If you are able to prove these 3 vectors are coplanar, you proved all the 4 points are coplanar. So first find out AB, AC, AD. It's not given. What are these? These are nothing but the position vector. OA, OB, OC and this is OD. Okay, these are not the vectors, these are the position vectors. Okay, so let me find out first AB. AB andre OB minus OA. So 2I minus 4I minus 2I, 4j minus 8j minus 4j, 6k minus 12k minus 6k. So this is vector AB. Next AC, OC minus OA, OC minus OA, third vector in the first vector minus subtract ಮಾಡೋದು. So 3I minus 4I minus I, 5j minus 8j minus 3j, plus 4k minus 12k minus 8k. This is the second vector. Then AD, OD minus OA, 5I minus 4I, 8j minus 8j 0 minus 7k. Correct? So these are the 3 vectors. Now you have to prove that these 3 vectors are coplanar. Hey, prove ಮಾಡೋದು? Determinant find out ಮಾಡೋದು equal to 0 ಅಂತ prove ಮಾಡೋದು. So if you are able to prove these 3 vectors are coplanar, you can write the conclusion ABCD are coplanar. So it is -2 -4 -6 -1 -3 -8 1 0 -7. Then expand ಮಾಡಿ 0 ಅಂತ prove ಮಾಡಿ, your work is done. Okay, so let us check whether these 3 vectors are scalar triple product is 0. Okay, so -2 into 21 plus 4 into 7 plus 8 and -6 into plus 3. So ಏನಾಗುತ್ತೆ ಇದು? -42 ಇಲ್ಲೆಷ್ಟು 56 15 ಅಂದ್ರೆ 60 minus 18. This is -60 plus 60 ಬರುತ್ತೆ. So cancel, so 0. So we prove that 3 vectors are coplanar. If you able to prove that 3 vectors are coplanar, then you can write that the 4 points are coplanar. The 4 points are coplanar. ಅರ್ಥ ಆಯ್ತಾ? So this is a very important question, please remember. So to prove 4 points are coplanar, you have to prove any 3 vector. ಇದೇ find out ಮಾಡಬೇಕಂತಿಲ್ಲ ಇಲ್ಲಿ. This is easy actually. Always subtract second to first, third to first, fourth to first. Okay, so this is a better. You can find out any 3 vectors and you can prove that determinant is equal to 0. Understood? But remember, this is an important question. Okay, yeah. So next question. Find x such that 4 points are coplanar. Again similar pattern. Okay, find x such that 4 points are coplanar. I'll start writing the solution here. Okay, question is here, then okay, I can erase this later. Observe carefully now. 4 points are coplanar. Again, this what are the given data? OA, OB, OC and OD. What is OA? 3, 2, 1. What is OB? 4, x, 5. What is OC? 4, 2, -2. Correct? No? Yes. And OD is equal to 6, 5, -1. So in find out ಮಾಡಬೇಕು? Vector AB, vector AC, vector AD. What is vector AB? So again you can write in a points form. Okay, order triplet alle ಬರೆಯಬಹುದು, nothing to worry. 4 -3 1, x -2, then 4. AC 4 1 0 -3. AD 3 3 and minus 2. Yeah, right. Now find out its determinant and equate with 0. Find out the determinant and equate with 0. Okay, so scalar triple product must be 0 because it is given that they are coplanar. It is given that they are coplanar, so it should be equal to 0. So this implies 1 x minus 2 4 1 0 minus 3 3 3 minus 2 equal to 0. Correct? So expand 1 0 9 minus of x minus 2. Correct? Yeah, it's minus 2 plus 9 minus okay, plus 4 3 is equal to 0. So this is 9 minus x plus 2, sorry, let it be as it is here. Here it is 7 alva, plus 12 is equal to 0. So it will be 9 minus 7x minus minus plus 14 plus 12 is equal to 0. So it's 26 minus 7x is equal to minus 35. 26 9 35. So this implies x is equal to 5. So this is a value of x when 4 points are coplanar. When 4 points are coplanar, the value of x which is present as unknown in the second point is x is equal to 5. Again, this is a one important question, please remember, and for 3 marks. Remember this, both previous one and this one questions for 3 marks. Very very important, please remember that. Simple determinant expansion gote all the problem from vector triple product you can solve. Okay, so next question. Okay, so last question from the vector. This is also again very very important question. So ee moorali usually one question anta guarantee 100% keltare. Nenpili important question, observe carefully. The sixth question and the last question from this chapter, vectors. Okay, show that the vectors vector a comma b and c are coplanar if vector a plus b, b plus c and a plus c are coplanar. Okay, so we have to prove that a, b, c are coplanar if these vectors are coplanar. So proof is like this, observe carefully. First you prove that, okay, find out first scalar triple product and prove that these three vectors are always equal to something. Okay, first we will find out the scalar triple product of these three vectors. First we will find out the scalar triple product of these three vectors. Observe carefully. This is nothing but vector a plus b dot vector b plus c cross vector a plus c. Okay, right, using the definition of scalar product, scalar triple product. So this is nothing but vector a plus b dot b cross a plus b cross c plus c cross a plus c cross c. C cross c, 0. Whenever you take the cross product with itself, it will be 0. So only 3 times. Again multiply vector a dot b cross a plus vector a dot b cross c plus vector a dot c cross a. ಆಯ್ತಾ, ಇದು a ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಪ್ಲಸ್ b dot b cross a plus vector b dot b cross c plus vector b dot c cross a. Correct? Now observe carefully. Here two vectors are collinear, so cancel 0. Here also two vectors are collinear, 0. This is equal to 0. This is also equal to 0. Here also 0 because collinear. So first and last remains. So the rest remaining terms are vector a dot b cross c plus interchange ಮಾಡ್ತಾ ಬನ್ನಿ. b ದದ್ದು c ಮಾಡಿ, c ದದ್ದು a ಮಾಡಿ ಅಲ್ವಾ. c ದದ್ದು a ದದ್ದು b, a b to c, cyclic order, first property, second property. ನೆನಪಿದೆಯಾ? So this is nothing but 2 times vector a b c, scalar triple product of two vectors. So ಇದು ಒಂದು separate ಆಗಿ ಒಂದು important question ನೆನಪಿರಲಿ. Okay, as a separate part, this is also one important question for 3 marks. Now this is a part of this problem, but ಇದು individually ಕೇಳಬಹುದು. Prove that vector a plus b, b plus c, a plus c is equal to 2 times vector a b c as a separate part. Remember that. Now I'll show you how to use this result to solve this particular problem. In Collinear, here show that the vectors are coplanar if 3 vectors are coplanar. Now if vector a plus b, b plus c and c plus a is coplanar, then what will happen, tell me? then the scalar triple product will be 0 alva. You know this property, you know the scalar, okay, this property 0. So this implies 2 times vector a comma b comma c is also equal to 0 alva. Yakeli we already proved it's nothing but 2 times of that. So this implies, which is 0, scalar triple product of abc is 0. So this implies in baribodo vector a, b and c are coplanar, so this is a proof of this result. ಅರ್ಥ ಆಯ್ತಾ? ಇದೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ನೆನಪಿಲಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಫಾರ್ 3 marks. ಇದನ್ನು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. So we completed the chapter called vector. So next my topic is scalar. Next my topic is 3D geometry. Again it is a continuation of the same topic, vectors only. So they are usually ಒಟ್ಟಿಗೆ ತಗೊಳ್ತೇವೆ. So 3D geometry. So please whenever you see the next video, that is 3D geometry chapter, you come with some preparation for 3D geometry first PUC. ಅರ್ಥ ಆಯ್ತಾ? So we completed vectors, one more easy and simple chapter. ಅರ್ಥ ಆಯ್ತಾ? Thank you.